I was scanning a digital map grid, searching for the specific city my brother had described as his ideal retirement spot. I found a name and felt an immediate, total certainty. My internal map verified the location instantly. Yet the River Mosel, the very thing that defined the town, sat 100 kilometers away from the spot I was staring at. After minutes of fruitless scrolling, my partner leaned over and pointed to a different spot, right on the water, the actual city. This error was a demonstration of the brain functioning exactly as designed, prioritizing confidence and narrative over geographical data. Cognitive science reveals that human memory operates by reconstruction. Every time you recall an event, you overwrite the original data, essentially rebuilding the scene from scratch. These anatomical sketches highlight the machinery involved. The prefrontal cortex manages our reality by deliberately suppressing specific memories. This active forgetting allows us to generalize information and regulate our emotions. It is an evolutionary adaptation that maintains our mental currentness. Despite the biological logic, the natural erosion of memory that comes with age is a persistent worry. I attempted to bypass this by creating a permanent digital backup. We turned to artificial intelligence to bridge the gap between our shifting biological records and the need for static, reliable facts. For 3 months, I fed an AI system every note, rule, and shortcut I owned, wanting a digital colleague with perfect memory. The result was a system that spent 3 hours untangling its own accumulated context before it could even begin the work I'd actually requested. It began mirroring my own map mistake. It would cite outdated decisions and non-existent files with total, terrifying confidence. My own error was checked by a flicker of doubt and a physical partner. The machine lacked both the internal skepticism and the external correction. Infinite digital storage creates a highly confident, hallucinating echo chamber, failing to provide the second brain we expect. This timeline shows the lost in the middle phenomenon. AI models process the start and end of a long context, but ignore the center. Performance drops by up to 85% based on memory length, causing a structural failure. Industry reports call this context rot. It is a flaw inherent to the current architecture of leading models, appearing long before the technical memory limits are reached. Passive digital storage fails for the same reason biological memory does. The structure itself has limits. Effective use of AI requires us to stop trying to make the machine's memory a copy of our own. The machine's true strength is the ability to connect dots across disparate domains and massive datasets at a speed impossible for the human mind. Our role shifts from the accumulation of data to the curation of meaning. The discipline lies in deciding what was worth keeping in the first place. Digital memory provides a mechanical lever for human intuition, magnifying our ability to see patterns across the noise. The depth of the machine's connections is dictated by the sharpness of our questions. We determine the quality of what is pulled back out. An AI will listen and consolidate information without tiring, but it lacks the internal doubt or physical grounding required to verify the truth. Symbiosis requires the human to provide the physical reality the machine cannot perceive. We must act as both the flicker of doubt that keeps scrolling and the finger on the screen pointing at the water. This partnership allows human intuition and digital scale to balance each other's structural limits, creating a mind far more capable than either could be alone.